Всем привет! Спасибо, что пришли. В этом зале
Everyone.
целый
So
день
thank
сегодня
you
говорили
for
исключительно на
coming.
английском,
And today we
поэтому и
had
говорили
most of the
о
presentations
таких
in English.
крутых
Actually, all of the
космических
presentations
вещах.
were in English, and people talk about
Говорить о таких
the
простых, очевидных вещах стрёмно. Но попробуем. У нас
like
есть
the
с вами
very
естественный
sophisticated things
ограничитель.
similar
Средний
to
доклад
space
сегодня
shuttles.
сразу
But I will
покушать, поэтому
make
постараемся
quite
быстро.
a simple presentation about much more simple issues.
Знакомимся.
So, and after that we'll have a
Меня
cocktail
зовут
party.
Шаломович Максим.
My name is Maxim
Как видите,
Shalomovich,
экран
and
растянут на лицо.
well,
Я
my
работаю в компании Lanit. Работаю
photo was a
системным
little bit
архитектором.
distracted by the screen. So
Компания
I'm
Lanit,
working in the Lanit
такая
company
компания,
as a
которая
system
занимается,
architecture.
в принципе, много чем,
The
но
company of
конкретно я
Lanit
работаю в
is
подразделении, которое
doing
занимается
a lot of various activities, and
заказной
I'm working
разработкой
in the
информационных систем.
department for
То есть фактически
custom,
мы
for
разрабатываем
tailored
крупные государственные корпоративные
systems
информационные системы на заказ,
for
выполняем
state authorities,
функционализ,
for
проектирование, разработку,
other organizations,
сопровождение
and we
и
provide turnkey analysis,
много
development,
интересного.
follow-up, and
И я, как
all other
правило, в таких
associated
проектах
activities. As a rule,
выполняю роль
within these
архитектора
projects,
решений,
I'm
решения различного уровня.
solution
Это может быть проектирование всей
architector.
системы,
It
это
can
может
be
быть
various
проектирование
solutions. It can be
отдельными частями,
designing of
зависит от масштаба.
the whole
И
system
в общем,
or
например,
some part of the system
проектирование
or
программ.
designing of software.
Собственно, в рамках таких
So
проектов я
within
обычно общаюсь
such
активно с
projects,
аналитиками,
I'm
общаюсь с разработчиками, с менеджерами,
very
и всем
actively
промываю мозги.
communicating with
Они меня все не любят,
developers,
вот такой
analytics,
человек.
and they don't like me
И
because
на
I
прошлой
try to
конференции
impose
Analyst Days
my
у нас была
ideas on
небольшая
them.
дискуссионная секция. Я и еще
Well,
два товарища из
also
архитектуры, один из них
I
коллега.
here in
У
this
нас было
event I
несколько
have
докладов.
two colleagues who made also some presentations, quite interesting, I believe, and we came here to talk about the work of an architect, about architects in communication with the analytics. So the second presentation was about the history of analysis and design, about a very interesting concept of interaction of analytics and architects. And my presentation was dedicated to the work of an architect within such projects of tailored, customized project. I tried to explain various approaches, models, people who interact, and an architect is needed in some of them, he's not needed in others. And when there was Q&A session, one of the ladies took the mic and she said that it was very interesting, but I didn't really understand what is the core activity of an architect. And that's why when I was preparing to this presentation, I decided to tell you about something more like simple, basic, without space flyers, something more like concrete. I'm a person being responsible for a system architect, together with my colleague, is most focused on. And the analytics, my friends and my colleagues, how can they support us in this within this activity? What are analytics actually doing? Actually, they have to do everything, but what is the most important thing? Well, the answer to this question is that this is the requirements. Well, maybe it's a little bit primitive or some simplification, but actually we arrived at the conclusion that the requirements that are provided by our analytics, our colleagues, is the most significant factor that influences the architectural solutions, and that's why we've decided to talk about that today. So I will try to tell you about that, about the requirements which are the most important for the architecture and why. And also I will share some ideas, tell you about some tools that you can use. So, well, if at the end you will tell me that this is not new and this is not correct, then please wait a little. I will explain to you how to use it in the right way. So what is that actually? What are the requirements to the architecture? If we ask this question, so the correct answer will be these are the requirements which influence significantly the system architecture? Well, it's a useless answer, but it's quite like basic because I was looking for various definitions. I was looking through various books and materials, documents, and not only some high-level materials like open group materials, but also books which were made for the developers who decided to become architects, and so for them, because a developer just needs to know what are the architect solutions are, requirements are. And why is it important to talk about the architect requirements? And in which way are they different from other like non-architectural requirements? First of all, they are helping to take decisions related to the architecture, and so these are basic things which give the basis to take the decision. They help to restrict the scope within which we work to take more or less correct decisions, and actually we need them for the sake of that. So there are a lot of requirements, and in the terms of reference, does anyone of you works with the state standard, GORST? Do you write some terms of reference? Only 3 persons in the room. Well, but we prepare a lot of terms of references on GORST, and although this is an concept, there is a concept that one terms of reference is enough, but now we come to the conclusion that the concept should be simple, but actually nowadays in the terms of reference we have a lot of details and they're changing quite quickly. But the architectural requirements I'm telling you about, they are in the perfect world. We need them to build an architecture on them. And another very important consequence is that they are needed at the initial stage. And if we really believe that the flexible development means that you can change it afterwards at any stage, then that is not exactly so. So the basic rules, the architectural concepts are very important for us at the initial stages, and we cannot develop them later. We should not. We have to recognize them earlier. But it's not very easy. If you can, if you really can do that so easily, you can come and join us as architects. This is the best option, because not all of our analytics can do that, actually. And if we try to break down the architectural requirements into categories, so we can define 3 of those. These are restrictions, quality requirements, and some functional requirements. And the first 2 categories sometimes are referred to as non-functional requirements in literature. I won't use this term. I will just name them restrictions and quality requirements. But normally, if non-functional requirements are mentioned, these are those first two categories. What are restrictions? Restrictions are decisions already taken, which are existing in the system and which restrict the system. As sometimes we make state standard terms of reference for state standard, so they develop these requirements at the very first stage, and they are really restricting the possibility to take decisions, and the very good quality of these decisions, which is very often ignored, that they are never to be changed. So there are 2 different restrictions. First, that it should be only these ways, no other way, or the second option is that it should be this way, but it can be changed if necessary. So the second, the latter practice is bad practice. So the restrictions should never be changed.
And since you cannot break these rules, since you cannot go beyond restrictions, you should be very serious about providing reasoning for them, so they must have reasoning behind them. What kind of restrictions are we working with in practice? What kind of requirements refer to restrictions? Three most popular ones in our goals and in our technical requirements. The language of coding, the software, and licensing. Usually, if you remember the technical requirements for GOST, then maybe the requirement for licensing and patent frequency. Usually, these requirements are reasoned, really reasoned, if the customer and it doesn't matter whether it's your internal customer or external customer, whether they have a limitation, for instance, IT strategy or licenses for some software have already been bought in advance, and they're just telling you that only for this software they're going to produce something. And another option is the language of coding. Coding language. Very often the organization is doing development. For instance, we have Java department, Java development department. We can say that let us develop the software on Java, and here there is the restriction that I'm speaking about. These requirements should not change, and if in the middle of the second release we realize that, well, Java is okay, but probably we'd rather code this on PHP. I hear people don't like PHP now. Please don't kill me for PHP. But we can do it. We can hire a small PHP team. They do it for us really fast. And in this case, this restriction makes no sense. Oftentimes, they are dealt with in the following way. Requirements with licensing says that the software must be developed with open source code. It's very related to import substitution, but very often they are doing this way. The system must be developed on open source code, and if you improve the performance characteristics, then it can be a proprietary software as well. Question. What's the point of this restriction? In terms of the quality of restriction, it's no quality restriction, because you can't measure it, and in case if someone tells you that the check of this requirement is so you need to provide reason, and you need to provide grounds that in this case you must use proprietary software, in this case you should not use it, then most probably it makes no sense. So here my urge is very simple. You'd rather not record these restrictions if you can avoid recording them. The next type of restriction is a bit more technical requirements. Requirements to the type of software and the capacities and capabilities of software. Again, if it refers to requirement specification. Again, these things are usually written through if the customer has a pool of equipment, if the customer already has some decisions made, or maybe you're just updating the system that's been there for some time and that exists already on this kind of equipment, and you just have no choice. In all other cases, just like in the previous case, you'd rather not record it, you'd rather not document it. And my favorite one restriction, the most tasty one, requirements to information security in terms of regulation. This sentence exactly in the example that the software is the state software system must be in line with law, federal law 17 stack, or whatever the number of the law is. Exactly this sentence causes a lot of restrictions for technologies, for development processes, for organization, an enormous number of restrictions. And if you document this restriction, if you agree this restriction, then in the end, and if you really have to abide by this rule, then you can say you can presume that all the previous restrictions make no sense. My brief advice on working with these requirements is, if you can avoid documenting something and recording, please do not document restrictions. Developers, architects, and the operating department will be really grateful to you for this, because modern approaches to development and modern approaches to designing systems, designing software, saying that we must have freedom as much as possible, we must have freedom to choose tools, for our tasks. And these kinds of restrictions and limitations in practice, they are really painful, and usually in practice they're being violated. And if it's a state-owned software system, then and if you violate these limitations informally, then it causes some problems. And if you document these rules in a way that you can violate them, then they make no sense at all. But there's one exception. Requirements on eBay in terms of regulation, please record it. Before me, there was a presentation about requirements to security. Unfortunately, I wasn't present there, but I hope they told you what are the requirements to information security, and the analyst must be aware of information security rules, information security requirements in terms of regulations, in terms of compliance with certain regulations. Please record it, please document it, even if they're not there. Please record it, because proving to the customer that he didn't limit you in the language of code and that's why you chose whatever you wanted, you can prove it to the customer, but you can't prove it to regulatory bodies and to law enforcement agencies. The next requirement is a requirement to quality. Here, there's quite a poor definition. The definition which is usually given by a quality attribute is features of the system and expectations of the application of the system. In my mind, this definition makes no sense. Usually quality is bless you. Usually, the quality is how well the system can do something, how well you can do something in the system, how well you can deal with the system, on the system, with the system. In English-speaking literature, you can see this great term such as abilities, and I love the term abilities because abilities encompasses all the requirements to quality that are really the foundation to the great architecture design. Quality requirements are split into two parts. Quality requirements and features and timelines related. Design time for quality for internal structure, for external borders, for repetitive use, and ability to modify and the ability to change and update, and runtime quality as well. So design time quality and runtime quality, it includes everything: reliability, scalability, information security, and information security, the real one, the normal one. So what are the requirements to design time quality? How do we usually work, and what are the most popular ones? Requirements to internal structure. Let me complain here. I have to complain here. Our analysts really love doing requirements such as the system must consist of these subsystems or components, just in order to phrase it nicely. It looks nice in the document, but in practice, then, you have to drag the structure after you to the very end, and some customers had to prove numerously that the sub-storage system just doesn't exist. And a subsystem of cooperation with the user is not a subsystem, actually, it's something else. And there are many user interfaces and many services, and they just couldn't understand why monitoring subsystem does not monitor anything. And the first example is quite innocent, because it sets the guidelines and principles. For instance, the requirement subsystems must be independent from each other. And well-known principles of poor connectivity and something else. It must be innocent, but it makes no sense. It's useless, because architects and developers, they will do it by default anyway, and checking these requirements is a hard thing to measure it. So in this specific case, if you have a chance to avoid these requirements to internal structure, you'd rather not. Requirements to external environment or to connectivity with external systems, so it might be called differently, but there's one point. Here we describe what's around our system, what other softwares are around our software, and what is the purpose. Very often we focus on protocols here. For instance, our software is designed to produce functions to other software according to HTTP or TCP. It's specified in a way like it can focus on any other software, but actually you should focus on the functionality. You should say what tasks, what business tasks, for instance, are done by our software, and what business tasks are done by external softwares, and we're just using the output of the work. If you listen to Roger, and he told us a lot about business architecture, and he did it in a very cool way. And there's such a thing as context in business architecture, and I'm sure you've seen multi-context diagrams. So these requirements, the way to describe them and to describe them in the architecture is context diagram. So the system is like a black box and what's around it. It's a very useful requirement. But the main thing here is to focus on tasks that are sorted by other softwares in the interest of our software, or in the other way around, our software is sorting out some tasks for other softwares, and the level of codification or the ability to develop and to evolve usually it's perceived in a relaxed manner, like the software must have a future, might have something built into it. Here, I presume we should focus on answering questions: what functions exactly should the system develop further? And it's very important to agree and to clarify in advance how these functions can be changed and updated. Because, for instance, you might say that the software must have a chance to expand integration in terms of new integration interface, and your customer will decide that this is the thing, that your software must have a certain integration machine, and without your participation, somebody can add some new interface, and you will have to, and you count on it that the customer comes to you, pays you some money, and you will add another interface, and they will perceive it like they can do it themselves. So here it's important to answer this question: in which part the system should develop and how the system should develop, through configuration or through updating. And these requirements are setting for anyone, for the architect or a design person, they are putting these points of expansion for the future. It allows to make the system more usable for the future and for development. Since we're speaking about flexible development and evolution architectures, I believe that this is one of the most important requirements, and the solutions related to this are one of the most important ones in contemporary information systems. A little bit more. I beg your pardon? Let's speak about runtime quality. This is the runtime quality. This is how the system behaves when the users are using it and when anything else works with it. Reliability and availability. Most important questions here, which must be recorded. The level of availability of the system, RTO, RPO, and the model of downtime. If you know the answers to these questions, okay. If you don't know, please Google it. These are one of the most important characteristics, and many basic solutions are based on it. Failure pattern. Scalability requirements. I think they are the ones that are undervalued. I think that these are the most important requirements, so the type of scalability and the part of systems with what types of scalability must be there. You'd rather record it as well or document it. And let me remind you that the scaling can be horizontal, vertical, and it's favorable to record which parts of software must be scaled vertically and horizontally, again, in case if these terms are not something that you're aware of. We can discuss it later, and I can clarify it for you if you're not aware of this, or I can answer your questions now or later. And requirements to information security. Here, again, if someone was at the previous presentation, I'm sure you heard about it. What are the requirements to information security as a whole? Information security requirements are sometimes functional, meaning the software must have authentication function, must have something else, and requirements that all the data stored on the system must be encrypted, and in requirements to information security, well, they impact a lot the architecture of the system, so please document them as much as possible. I believe there are many interesting uh, books and templates of these requirements, and Denis Beskov had like an example of a set of these requirements, and you could just apply it to any system, to any software. Just cross out what you don't need. So he had a pack of templates. Performance requirements. They're in the end, and let me explain why they're in the end. If you're developing a software for real cloud meaning the supply of resources on demand, automatic scaling, then these requirements must not concern you actually in the beginning. Or if you're developing the software that will be deployed on your favorite servers or in a data center, then these are going to be very important requirements, and we are guided by them a lot. Usually, these indicators are hardly ever guessed from the first attempt, so please document them as much as possible. Record them, but I recommend to focus on the previous points, previous quality requirements, and if the system is implemented with a good horizontal scalability, then in this case its performance is going to be quite great, thanks to this alone. And advise how to reveal quality requirements. Quality scenario technique, this is what can help you. Let me brief you design it. There are a few methodologies of this kind, and they're saying that quality requirements, non-functional requirements, are also great at scenario types. So you should write scenarios. There is a whole structure of the scenarios. In simplified manner, incentives, so something that triggers you, an object, so what this impact is aimed at, a software or a part of the system. Reaction or response. Response, what the object is doing in response to the incentive, and measurement of the response. For instance, in case if a user is doing function A, the system sends the result or report the error in 95% of cases, no more than in 2 seconds. It's a very good way to describe requirement quality, or to describe some acceptance criteria or testing criteria, or at least to reveal, to document somehow these requirements, because building these scenarios helps find out all the situations that must be taken into account when designing the software. In case if the server goes down, and it ensures the storage, the system, the software must not allow to lose the data. Usually this methodology is done to test runtime quality. I also offer to use it for design type quality. For instance, if you're supporting the new interface to transfer the data, you should be able to update the system no more in 4 days. It's a measurable indicator, it sets a limitation, it sets a quality limit. And when the architect and developer and technical experts are designing the software, they're going to be taking into account exactly your requirements, not some abstract phrase, some vague words that...
And finally, the functional requirements. So among the functional requirements, there are so-called architect drivers, architect requirements, and actually there are some definitions. Some definitions like the most significant functionality for the business, or a definition like the functional requirements which influence the architecture. They are no help. They have to be defined in practice, like we take the functional requirements and start reading them. We read them and we understand that this and that things have to be taken into account. So I have tried to prepare several things to tell you about some things on which you have to put your focus on and which influence the architecture mostly. First of all, this is the business function. If some of the business function is very important for your customer or for the stakeholders, so then the architecture of the system have to be based on that. So, for example, if you are developing an architecture which has to be reporting system, so in this case you have to build it up based on the principles of reporting, and the architecture has to follow. And another function is the search function, whether they are direct or indirect. So there should be some options to search for information, and that requires various architectural solutions depending on the requirements, on their scope and other indicators. So next function connect with the historical data, and also sometimes you need to change the historical data. For example, we have to make a transaction for the day before, for the previous day. This is the reality of our country, and it also influences the architecture. Also, the functions which require addressing external system. When we talked about this system, we mentioned that we have to define which functions are purely for the sake of our system and which are for some exterior systems, and which exterior systems can implement some functions which affect our system. So I mean that we have to set up a good interaction of the exterior systems and to provide for a good interface of all these components. So this is kind of also an architectural decision. So some hints on time characteristics of functions. So for example, this has to be available online, and when addressing it, we have to see the results of the previous changes or amendments. So any time characteristics, they indicate at some architectural solutions and requirements. So hints at the reliability of the functions. So for example, if it was not possible to implement this operation, so the data has to be not lost, or they have to be rolled back to the initial state. So also an architectural requirement. Also hints to the duplicated control of the requests and response. Do you know it importance hints for its importance in behavior description are significant because they are based on the principles on duplicating control, status control, etc. So, and what are the recommendations to detect these architecturally significant things? So, first of all, this is the use case technique, which can be used in the alternative scenarios and exclusion scenarios. I think the developers, being reasonable, they use these techniques. The main scenario is good, but if in an alternative scenario it's stated that the customer has changed his mind and then you have to roll it back to the initial state, then it influences really hard the architecture. And also, if you remember the transaction flow by Jacobson, so it was stated that there are four main steps of processing of any inquiry sent to the system. So the system validates, processes, and then returns the result to the addressing party. So at each of the stage, any some alternative or exclusion scenarios can also be activated. So, and when you develop requirements, you have to take into account this structure, and there you have to also define some peculiar features which are significant for this architecture. So the result, the conclusion. So I tried to tell you about the architectural requirements significant for us. It doesn't really mean that all other requirements are not significant and they can be changed whenever you want, and they can be put in any format and shouldn't be taken into attention. But it means that me, for example, being an architect expert, I focus on them my attention. This is a priority for me. So try to also put questions in the right way. I try to give you some examples how to put the questions, and I think it was more or less clear based on the examples I gave you, and also make a checklist to verify all tasks, all statements, all terms of reference, and it will help you to verify those. So if you want to share your opinion about my presentation, please come tomorrow to my presentation at the bar camp. There will be a slot booked for me, and also join our company and teach us the right way to do this work. That's it. If you don't want to go to the cocktail party yet, so please ask your questions. Thank you for your presentation. It was really interesting. So what do you think about the role of the architect being fulfilled by an analyst or developer? Because in many teams there is no dedicated architect's position, and at which stages of the project the presence of an architect is obligatory, and are there any stages where there can be no architect? So from the political point of view, from my point of view and from the point of view of my department, architect should be present at all stages. But actually, in the presentation at the previous conference, I tried to give fair answer. It depends on the scale and type of an organization. Sometimes now the large projects are being broken into smaller components, smaller teams, and also the contemporary approaches to the architecture allow for that. And also, if you mean that the team is only 3, 5, 7 persons, including developers and analysts, then the architectural solutions, which I call architectural, like basic elements, like general elements, interconnections between them, basic principles, patterns, so they can be processed by analysts and developers, because analysts know the business side of that and the developers know the technical side of that. Me, being an architect, understand both, but don't have deep knowledge in both. So that's why, as an architect in such projects with this breakdown of the team, so I'm normally working in the projects where the architecture or basic solutions are developed, which can be replicated among other team members to give them a component, and they will use it and they wouldn't need me. Or I can fulfill a role of a third-party person, just providing advice on some issues. I think at certain stages the project will become more efficient if the architect is involved at earlier stages, and he should not provide just some cubes with arrows. This is what I've shown you in this presentation. And it's not just diagrams, cubes, etc., but to set up boundaries within which a team of analysts can work. So it's like API, etc., etc. So I mean, at the initial stage, I think an architect has to be involved, but then he has to be used as a consultant. And also, if the requirements I told you about change, and they can change. An architect has to review the architectural solutions, and that's a good option. Well, and this is actually the answer to the second question. And the answer to the first question is that if a project is small and an analyst has to know well the technologies, it's important, and accordingly he doesn't include some things that cannot be fulfilled in the terms of reference, and the developer has a good understanding of the concept. Team lead is normally senior developer, so that collaboration normally brings wields very good results. These are very often projects with small budget, and the mistakes in these projects are not critical. And in many organizations, analysts work as architects or solution architects. And me personally, I worked as an analyst as well. Do you understand something about that? So the last question. Unfortunately, we are limited. The time is limited. You mentioned that the architect has to participate from the initial stages of the project. This will be most efficient. And how come that in the terms of reference you've got existing subsystems, and you have to prove to the customer that there are no such systems? Well, I recommend to do it this way, but it's not always the case. Honestly, we try to participate in the terms of reference development, defining the architectural requirements, but this is not exactly normal, because analysts are normally responsible for the requirements, and so they get a checklist. Yeah, we will give them. We haven't done that yet. So I have formulated the task now properly, and then it will be easier for them. And for the customers in large state organizations, they have an initial stage of coordination and approval of technical concepts. In this process, neither of the contractors is involved. A customer comes and he has terms of reference attached to the contract, and the subsystems are included in it. So you don't see the list of the subsystems until you get the terms of reference. Yeah, well, in this case, that's it. That's like that. But also, sometimes analysts write it. But, well, subsystem is a subsystem. There are functional and technical subsystems, and they can be mapped like that. And it's quite sad sometimes. Thank you very much. Hope you are not tired with my presentation. We have a couple